Harshini, let them, the participant will join, okay? We'll start. Shall we start that? Yeah. Who is going to give welcome address? Yeah. You may ask her to do.
Good morning, everyone. Welcome to the third day of a workshop on next generation intelligence, machine learning, and deep learning systems. Having covered model performance and feature engineering previous session, we are now ready to explore the two most fundamental pillars of machine learning, classification and clustering. Today, we are privileged to have one of our own experts lead the session. It is my pleasure to introduce Dr. P. Vinodhi Lakshmi Ma'am, Professor, Department of Computer Science and Engineering. Dr. Vinodhi Lakshmi is a distinguished academician with a deep specialization in intelligent algorithms. Her expertise lies in helping machines making sense of complex data, whether that means labeling it through supervised classification or discovering hidden patterns through unsupervised clustering. In today's session, she'll guide us through classification, mastering algorithms that categorize data into predefined classes, and clustering, understanding how to group unlabeled data based on inherent similarities. Her practical approach and technical depth make her ideal person to bridge the gap between theory and application for these essential topics. Dr. Vinodhi Lakshmi ma'am, we are eager to learn from you. The virtual floor is yours.
Thank you, Harshini, for your intro. So, I hope my voice is audible, right? Yeah. So now I will share my slide. Harshini, start recording, okay? I hope my slide is visible, right? Okay, if anything, you message me, okay? Okay, now I will start. Okay, good morning to all. So today we will see about the classification and clustering in machine learning. So first of all, from the last two sessions, you somewhat know about what is machine learning, right? So machine learning is nothing but it's a technology, right? It's a subset of AI. So what is machine learning? It's a technology where the machine will learn like a human. Okay, so before this, how the human will start to write program. So we already started the program, right, to write. So how we started, our teacher thought how first thing we want to write the aim, and then we want to write the algorithm. After that, we want to write the program. Okay, so in algorithm, we can write some logics too. So this is the flow we follow to start learning. So likewise, the machine also learn from these steps. So how? So from the aim. So where the machine is, the scenario, and where the data set. So everything is coming under A. And the next one, algorithm. So the machine will identify some algorithms as well as you can write, you may insert to the machine also. So after that, it will learn something from the algorithm. So with the data set as well as algorithm, the machine will start to write the program. So this program is nothing but model. So in the all the machine language, we have the general term called as model. Everybody says what is model, what is ML model and all. So what is model? It's like a what generic format. It's a program. So whatever input you are giving or inserting inject to the model or the program, it will give the output based on it, right? So similarly, the machine also learned from dataset as well as the algorithm, and then it generate the program called model. Okay, so in the model, whatever input, it's in the general format, right? So if you are giving the, we already studied in C also templates, right? So all the for all the data type, it's a generic type. So where whatever data type you are inserting, you will get the output based on the input. Okay, output based on the input, right? So similarly, the model also write the program in template format, generic format. Okay, so based on the input, it will create the output at called prediction. So how the machine is learned from the scenario means data set and the algorithm supervised. We have three types of algorithms in ML, right? Say supervised learning algorithms, unsupervised and reinforcement. So all these algorithms are exist based on the scenario data set and our recommendation. The machine will choose the algorithm and learn the scenario from it from the training set, right? So from the training data set, it will develop the model and it will check the accuracy based on the test set, right? So when the model will be generated during training. So during training only, the machine will generate the model. Okay, mind this. So in model, we have three generic factors. So first one features, another one parameters, another one is metrics. Okay, so you know somewhat about what is features, right? So all the models has depends these three factors. What are they? The first one features, second one parameters, third one metrics. Okay, so the first one features. What is features? So features are nothing but input variables used to describe the data. So what is it? From the data set, the machine will extract the features. So you heard the word, right? Feature extraction and all from the data set, right? From the input. So that is the thing, this one. So what is feature? Feature is nothing but the input variables used to describe the data. Okay. So say for example, if my data set is house price prediction. So what are the features I have in the data set? Maybe number of rooms, area, location, where it's placed, and square feet. So these are nothing but the features in the data set. So what is features means the input variables used for describing the data, right? And the next case is what? Parameters. It's very important one because the parameter are the internal variables of the model, okay, that learned during training. So mind it, when I say the model will be generated only
Ma'am,
at the training phase. Okay,
ma'am,
what happened?
ma'am, we are able to see only your first slide, ma'am.
Okay, okay, yeah. 1 minute. Now it's visible.
Yes, ma'am.
Okay, so I'm giving intro only now. Then I will change. Okay.
Okay, ma'am.
Okay. The next one. Okay, I will continue. So the next factor is parameters. So what parameters? The parameters are the internal variables. Okay, now I am giving some general term before enter into the topic. Okay, what is classification and clustering? So first, I hope you know somewhat what is machine learning. So generally, you know what is machine learning, what is model and all. So I am giving some basic intro about what are features, parameters, and metrics. Okay, so first we have seen already features. Now we are seeing parameters. So parameters are what? The internal variables. Okay, so internal variables of the model that learned during training. So I told you already the model is generated while training. Okay, so while training the model is generated. So while the model is generated, the machine will generate some extra features, not a features, some things, right? So that is called parameters. So they are nothing but the internal variables of the model. Okay, so it helps to develop the model. Okay, so before model generation or while during model generation, the parameters are used. Okay, so in the parameter we have two types. It's a hyperparameter, another one non-hyperparameter. You heard the word, right? Hyperparameter and non-hyperparameters. Okay, so hyperparameters are nothing but user-defined variables. So user-defined before model generation, okay, or before training. So before training, the user will set some variables that are called hyperparameters. The examples are nothing but if you are used in deep learning, you will know about the apertures, batch size, number of clusters, learning rate. So these are nothing but the parameters set by the user. So it is called hyperparameters. Okay. The second case is non-hyperparameters. So non-hyperparameters only set by the machine, not by the user. Okay. So they are learned automatically during training phase. So examples are weight, bias, centroid position and all. You heard the word, right? Weight, bias and all. So last two sessions you heard what is weight and bias. So weight, bias are nothing but the non-hyper parameters set by the machine while model generation. Okay, so these two parameters, why I am explaining these two means because in classification and clustering, these are the factors involved. Okay, what is hyperparameter and non-hyper parameter? You can say, so what are the hyperparameters we have in classification and what are the non-hyper parameters we have in classification and clustering also. Okay, so that's why I said, so parameters are nothing but the internal variables. Okay, so internal variables of the model are learned during training. Okay, there are two types, hyperparameter, non-hyperparameter. Hyperparameter na set by the user, non-hyperparameter na set by the machine while training, okay, or model generation. Okay, then last factor is metrics. You know metrics, right? Last session, Selvi ma'am has taken that. Okay, what is metric? So metrics are nothing but evaluation measures. Okay, used to assess model performance. Okay, last time ma'am, Selvi ma'am explained what is recall, F1 score, accuracy. I hope you can remember it, right? So the metrics are nothing but the measures used to explain or assess the model performance. Okay, ma'am. So these are coming under the metrics. So these three are the general informations related to model. What are the features, parameters, and the metrics? So features now, it describe the data you can take from the data set. And the next one, parameters. Parameters are the internal variables that can be learned during training. And the third one, metrics. Metrics are nothing but evaluation measures for assessing model performance. Okay, now we'll start our topic. Why I explain this means, so parameters, these three factors mainly involved in classification and class. All the models, these three factors are dependent, right? So anyway, in classification and clustering, I am going to discuss about the parameters also. That's why I explained all this. Okay. Now we'll start what is classification. So what is classification? Classification is a supervised learning technique. You know what is supervised learning. So what is supervised learning? Both input and outputs are known. Means it's coming under supervised learning. So the machine will, for classification, it will use these default algorithms which are available. Okay. So classification is a supervised learning technique where a model learns to categorize data into predefined class or labels. I told you its outputs are known. So whatever data you are giving, the data they predict which class, which predefined class it depends. Okay, so this is called classification. So classification is a supervised learning technique where the new data will be classified, predefined. Okay, will be classified to predefined class or the labels. Okay. So why classification? Mostly why classification? For decision making, right? And then for decision making, prediction, decision making, and then what? Automate manual work, identify patterns in data. So for all these cases, we need the classification. And the next one, what are the classification algorithms are used? So in the ML, defaultly you will use Python for ML model generation and all. So the classification algorithm already exists with the Python packages, no? So KNN, logistic regression, decision tree, random forest, SVM, AD base, so gradient boosting algorithm, quadratic discriminant analysis and all. So today we will see about what is KNN classification. Okay. So KNN classification, as the name implies, K means K numbers. Okay. K mention the number, integer value, and NN represent nearest neighbors. So what is this classification? We already know what is classification. What is classification? Supervised technique where the new data will be classified or be categorized into the predefined class. So predefined class, we want to categorize the new data. So how we can categorize the new data? Based on the number of the nearest neighbors. So K represent the what are the numbers? Okay, how many neighbors you are going to consider for the new data classification. Okay, so KNN represent the number of neighbors you are considering for classify the new data. That's all. Okay, so KNN is a supervised machine learning classification algorithm which classify a new data point whose nearest neighbors are classified. So based on that, the majority vote of the neighbor class will be assigned to the new incoming data. So new data will be classified based on the vote for the nearest neighbors. They depends. Okay. They depend. So the next one, so the steps in classification. So we know what is classification and KNN classification also. Then how the procedure for KNN classification is choose a value of K. So K value we have to initially before training we want to set. Now K depends which parameter, hyperparameter or non-hyperparameter. Anyone can say? So K, I told you, K want to set before model, right, generation. So K value set by the user. So it depends which parameter, hyperparameter or the non-hyperparameter. Anyone? Can anyone say? Guys, am I audible, Harshini? Harshini? Okay. So first step is K in classification, first step is choosing a value for K. So we are going to set the K value. So if the value is set by the user, means K comes under hyperparameter. So I told you already, the hyperparameter means what? It's an internal variable. It set the value set by the user before training or before model generation. So here also in classification model generation, the K is used as a hyperparameter to set the values, right? And the next one, calculate the distance between the new data point and all training points. Okay, so now we know what is K. So how many number of neighbors we are going to consider for classification. And the next thing is what? We want to find the distance of the new data point with the neighbors, right? So how we can say these are the neighbors? Because the distance is very less, we can add the things are coming under neighbors. So we want to find the distance calculation. So mostly we use equal dn distance. We have a lot of sign distance are there. Okay, and then manhunt distance. We have a lot of distance algorithms are available. Mostly we use equal dn distance because of its simplicity. Okay. And the next one, select the k nearest neighbors. After distance calculation based on the k value, the number of neighbors will be considered who are closest. And then check the labels of these neighbors. Next one is what? So now we found the neighbors. Now we want to find the neighbors class. So based on the class, we can assign to the new data, right? The next one, the majority class among the neighbors become the predicted class. Okay, so we'll see the example. Before that, I gave some intro. That's all for KNN classification. Okay, so the next one is advantages of KNN classification. It's simple and easy to understand. Okay, no training needed. Lazy learning. What is lazy learning? You already know what is machine learning, what is supervised learning, unsupervised reinforcement learning, and what is the term used in ML? Lazy learning. So lazy learning is nothing but it will not I already told you, generally in machine learning what happened, the model will be generated during training phase. If it is the lazy learning category, the model will not be generated during training phase. The model only generate when the new instance will come to the case. Okay, so what is it meaning? What is lazy learning? Abhina, as the name implies, the learning strategy where the algorithm delays model building until a query is made. Means the ML approach where model does not build during training. The model will not be generated during training. Instead, it stores training data as it is and waits until test instance is given. Did you understand what I'm telling? Lazy learning means, as the name implies, generally in machine learning, the model will be generated during training phase only. Training phase, mind this. In the test phase, we are testing the model accuracy. That's all. But in the lazy learning case, the model will not be generated during training phase. Okay, it just keep the training data as it is. Then when the model will be generated in lazy learning means, the model will be generated only the test data is given. If you are giving the test data, then only the machine will, based on the experience, it will develop the model and then it will test. So this is lazy learning. So here you can reduce the complexity. The training phase is very less time, quick to develop the model, and all we have. Okay, we have the extra advantages also here, and it works well with small data set. Okay, one of the larger data set, mind this. So it works well with, it will work with larger data set also, but the accuracy is more in small data set than it's a larger data set. Okay, and then it's effective for non-linear data also, and naturally multi-class. So KNN is not only for binary class classification, it will used for multi-class classification also. Okay, and it's flexible distance matrix. We have many metrics also we can add to find the neighbors. And the next one, disadvantage. So each one has its own pros and cons, right? So the next phase is disadvantages of KNN. What is disadvantages of KNN? It's slow for large data sets. Okay, it will work, but it's slow, right? Okay, then high memory usage, because it stores the entire data set. It want to for processing. Okay, I will tell you, when we are seeing the example, you will understand this statement real meaning. Okay, so high memory usage must store the entire data set for prediction. And the next one, we must normalize the data. So we want to convert that into 0 to 1 case. So numeric data only processed by KNN. Okay, and then sensitive to irrelevant features. Why? Because we are going to see the nearest neighbors class. Based on that only we will do the decision making. So if the nearest neighbors are noisy one, what happened? The prediction will go down, right? Accuracy will go down. So the irrelevant features will also affect the model performance. So it is sensitive to irrelevant features. Okay. And the next one, choices of K is critical. We are setting the K value, right? There is nothing is behind K value. So we are going to set K value means, if small k is using its noisiest one, so the accuracy will go down, like unstable. If you are choosing big K means the big K value is K equal to 25, 28, likewise based on the data set size. No? So if you are setting the K value is big, it may mix different classes. Okay, the ambiguity will occur there. So we want to set the K in the standardized format. We'll see. Okay. So these are the advantages of KNN. Now we'll see about the examples of KNN classification. See here, so now we are going to do what? We want to classify the new data, right? So the new data is this one. So our goal is what? Classify a new student as pass or fail based on hours studied. So number of hours studied based, we are going to predict whether the new student will get pass mark or the fail mark. Okay, so this is the data set. So in the data set, you have three columns, right? Three input features you have: student, house studies, and the result. Okay, so A, B, C, D, four rows are there, 2, 3, 4, 6, and fail, fail, pass, pass. Now, what happened? Then new data. So, our study is equal to 5 given, and we want to find the student may be E. Okay, take the student name as E, and the our studies is 5. I want to find the result, whether pass or the fail. Okay, the prediction I want to do, fail or pass. This is the binary class classification, either pass or the fail. Okay, so here the first step is what? We want to set the k value. So k equal to 3. So k equal to 3 means the first step is over, k equal to 3. Now what is the second step? You want to calculate the distance, right? So we want to find the nearest neighbors. Based on the less distance, we can find that particular thing is a neighbor. So our new value is 5. So we want to find the distance, 5 minus 2, 5 minus 3, 5 minus 4, 5 minus 6. Okay, so distance we want to calculate. So here 5 minus 2, 3, 4 and 6. The distance are 3, 2, 1, 1. So who are all neighbors? Who are having the less distance? So neighbor C is a neighbor and D is a neighbor and the next one B is a neighbor. Why we are not taking A? Because K value is 3. We said already. So K value is 3 means what? We want to consider first 3 neighbors from the data set. So first 3 neighbors are all, who are all first 3 neighbors? So D, E and then B. So 3 neighbors are finished, right? So we don't want to bother about A. So we have 1, 1 and 2. So for 1, 1 and 2, B, C, D. So B, C, D, the result is fail, pass, pass. So these 3 neighbors we are going to consider, their classes are pass, pass and fail. So which is the major voting? Pass. So pass is occurred 2 times, than fail. It's only 1 time. So new data for this our study 5 for the person E, right? So assigned to the pass class. If the new person 5 means our studies is 5 means they will get the pass mark. Okay, that is the thing they explained here. So pass is 2, voting is 2, right, for pass class, fail class 1. So which is the major voting? Pass class. So we can find the number of studies has 5 means the student is coming under pass case. So the new student who studied 5 hours is classified as pass class. Okay. So this is the binary class classification. So next one, this is the calculation. So next one, another example we'll see. Okay. So another example is predict whether a customer will buy a product. So whether the customer will buy a product. So here the features are age and annual income. I told you what is feature, right? Internal variables, right? We describe the data. So features are age and annual income. Okay. So on the last one is whether they are buying or not buying. So 3 columns are there in data set. First column is age, second column income, third column is whether they are buying or not. Okay, buying or not. Our aim is what? The new customer will buy the product or not buy the product. We want to do prediction, right? So they have given new one is age equal to 30 and income is 48. So they have new given data is age 30 and income 48. We want to predict whether this person, new person will buy the product or not. Okay, so the first step of KNN is what? K value setting. So K equal to 3, again they set. Okay, so next step is what? Find the distance. So how we will find the distance? In the previous case, we have only one column, number of hour studies. But here we have 2 columns. Then how we find the formula for equality and distance? So equality and distance is what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Likewise, so this 30 is divided, subtracted from 22. Okay, so 22 minus 30 whole square plus this 48. 25 minus 48 whole square. So likewise, this age value is subtracted from each row age value and income is subtracted from each row income value. So finally, we'll get the distance values, right? So what are the distance values are very less, they are considered as a neighbors. So that's why they are doing this. So why they are using this one means because small normalization. What is normalization? I say, so all the values are converted into 0 to 1. 0 and 1 kulla we are converting. Why? Because to reduce the complexity. See, to process the 100 or 110, processing complexity is very high than processing 1, 2 and all. Okay, that's why the large values are converted into small values. That is called normalization, right? So in this normalization from 0 to 1, some standards they are converting all the values. So this is the normalization. For normalization formula, we are using x minus x mean by x max minus x mean. Means what? So in this column, which value is less? That is called x mean. So this is 22 is very less. Up x mean is 22. And which value is highest? 40. Up x min x max is 40. Likewise, y min is what? 25. Y max is what? 80. So that's why they mentioned here. So min is 22, max is 40, and min is 25, max is 80. So from this, all the values, the age as well as the incomes are converted into applying this formula, they will get the value. See here 22, 25 converted into 0000 and the class is no. Okay, they will not buy the product. And 25, 30, they are converting into normalization, applying this formula, right? So applying this formula, the value is 25, 30. So it's converted into 0.167. This is age and the income is 0.091. So all the values, look at here, all the values are between 0 to 1, not beyond 1. Okay. Likewise, the next value you see here, 30, 45 is converted to 0.44 and 0.36. So age is 0.444 and the income is 0.364 and the predicted class is S. Okay, given in the classes S. So all the values are converted into normalized. So it's, ma'am, this is the very small set. Why do you want to convert into normalization? You may ask, because this is the very less. If you have the bulk amount of data, it's difficult to process. No, that's why all the values are converted into normalized factor from 0 to 1. Okay, so okay, in the data set we have converted all this. What about new arriving data? New arriving data also want to normalize. Okay, so the new data also converted means what? This is the value is 30, right? So 30 and the formula see here. So 30 minus x min is what? 22. So 30 minus 22 by x max is what? 40. So 40 minus 22, always 80. So 30, 22, 80. It's also converted into normalization factor 0.44. Likewise, the new incoming value 48 is also 48 minus. So this is income, right? So income min is 25 by max and min, right? 80 minus 25. So we will get. So the new testing data, right? That also converted into normalization factors. So now all the values are ready. From this, you can calculate the equidistant distance. Okay. So equidistant distance, how will you calculate from this? So this value minus this value whole square plus this value minus this value. So for all factors you want to consider. So age and the income. Then you want to add these two based on this formula, you will get the value. So the first value is 0.61 and the second, this input no. So second row distance for the new incoming data, right? 0.42. So likewise, all the values are calculated for all six. Means what? This new data with the existing income, right? Existing data, distance will be calculated. So this value and this value is applied in the equidistant distance. Likewise, this value and this value and this value and this value. So you are applying this value. You are subtracting these two values from each row values and you are finding the distance. That is the thing happened here. Okay. So finally you will get 0.6, 0.4, 0.05, 0.3, 0.8 and 0.18. Here we want to find the minimum distance. Neighbors we want to find after this, right? Who are all neighbors? Who are having the less distance. So here the less distance, how many neighbors you want to consider? K equal to 3. So 3 minimum values you are going to consider. They are considered as a neighbors. So which one is the very less? This one is very less, 0.0540. So this is the first value. And the second minimum value is what? This one, 0.826. So this third one and the sixth one are the neighbors and the next minimum is what? This value. Fourth one, 0.3535. So who are all the neighbors? K equal to 3. So we want to find only the first 3 neighbors, right? First 3 minimum value neighbors. So who are all the first 3 minimum value neighbors? Row 3 and then row 6 and then row 4. So row 3, row 6 and row 4. So row 3, row 6 and row 4. So these 3 are our neighbors. So row 3 depends yes, row 4 depends yes, row 6 depends no. So the majority voting is yes. So for the given data, based on the age is 30, income 48, the customer will buy the product because it coming under S case. So the customer who are satisfied this condition, it's coming under S case. Yes, the customer will buy a product. You can say. So same thing is explained here. So yes, no, and yes. So we have two voting for yes and only one vote for no. So majority voting is yes. So the given data age 30 and 48, right, income will predict to buy class is yes. So the customer will buy the product. So this is for binary case. What about, so you know the general Python program, right? Okay, we'll see. Okay, so that is called binary case. And what about binary, more multi-class classification? So A, B, C. Still now we have seen one either pass or fail, or the going to buy the product or not. So likewise, so the KNN is suitable for the multi-class classification also. Multi-class means more than two classes. Okay, more than one class classification also. So here, look at here. So this is the given data point. Our aim is what? Classify a new flower into class A, B, or C using KNN. So the new flower you want to classify to whether it depends class A or B or C. Okay. So this is the given data set. So first case is what? Fine. Set the K value equal to 3. Why we want to set the K value mostly 3? So, but this is not the case. Mostly we are setting the K value as odd number. Why? Because the majority voting goes to the final prediction. So if you are choosing the even one, what happen? Ambiguity will occur. So 2S class, 2 no class, or even number of equal number of S and no class. Likewise, so ambiguity will be there. That's why we set the K value as an add value. Okay, well. So K values are maybe an add value. So same case. So here the points, features 1, feature 2 and the class are given. So the given point, we want to predict whether it depends A class or B class or C class. So same thing, what K value set first, then we want to calculate the distance. So how will we find the distance? This 4 is subtracted from all these x1 features and this 4 is subtracted from all this x2 features and using the equality and distance. So same thing is happened here. So this 4, this is 4, this is 4. So you want to calculate subtract all this. So this is the thing happened here, all 4 and all the x1 values and all second 4 and all the y values. We are subtracting, get the value. This is the distance. So K value is 3. So who are all the K values 3 means we want to find first 3 minimum values, right? So this one and the second one is this one and this one. So these 3 are coming under K3 values. What are they? Who are they? P2, P3 and P4. Right? P2, P3 and P4 are coming under minimum value. P2, P3 and P4. So their classes are B, A, B. Are you asking any question? Okay, B, A, B. Okay, the majority voting is B. So the given data is belongs B class. Okay, so in some cases, either you may get B, A and C also. So majority voting will be a predicted class. If in case multi-class classification, in some case, rarely you will get, if I am getting the outputs are B, A and C, then what will be the output? You may ask no. So in this case, they will give some solutions for it during ambiguity cases. So who are they or what are they? So choose odd K values, will avoid the ambiguity. Second one, distant weight voting. You can use. So who are the nearest, very near to the data? That class also you can assign to the new data. Or choose the class of the nearest neighbors. So here both are equal only, but here majority things you may consider. Here only one neighbor also you may consider. Who are our nearest? That class will be assigned automatically to the new data also. Or you can reduce the K value. Here you are increasing the K value. Here you may reduce the K value. Okay. And then using the probabilistic output also. So class probability also you can find and you can say the output. So these are the solutions given for ambiguity time. Okay. So we can't say this is the prediction. So KNN is not only used for classification, you can use it for regression also. So in the classification, what happened at the end column, output column, you have the classes, predefined classes. But what about regression? You have only the values. Then how you say the prediction. It's nothing but the same procedure. You want to find based on the k values you are finding, but instead of voting the majority class, you are taking the average. Did you understand what I'm telling? In classification, after distance, we want to find k nearest neighbor. If k equal to 3, we are considering only 3 neighbors who are all having less distance with the new data. Right? All 3 values classes will be taken and the majority vote will be assigned to the new new data class. Right? But if it is the regression, you are not having any classes, you have the values, continuous values. Then how you predict the value means based on this case. So after k equal to 3 means you are taking the nearest 3 neighbors, no, that output values will be taken and you are taking as an average value, and this average value will be assigned to the new class. So this is the example for it. What happened here? Predict the house price based on house size using KNN regression. Okay, ma. So in this data set, house names are there, size are there, price also there. So you want to use the KNN for regression case. So here house price in first case is what? They have given new house square feet is 90. So for 90 square feet house, what will be the price of that house you want to predict? Okay, how will you predict? The first step for KNN is k equal to k value setting, right? Here the k value is 3 set by the machine or sorry, by the human. The next one, distance calculation. So distance calculation is when this 90 is subtracted to all the size, okay, size of the houses. So 90 minus 50, 90 minus 60, 90 minus 80. So likewise, you can subtract. So in the subtraction, the first minimum value, where will be the minimum value? Here, 10 you will get. So house 3. Next, you will get this one, 30, right? Here also you will get 10, H4. So that's why likewise 3 nearest neighbors are taken and these 3 values are average. So you will get 50 lakhs. So this 50 lakhs is the predicted house value for the square feet 90. Okay, so likewise you can use KNN in regression also. So this is the Python program using KNN. So next one, if we have the time, we will see the Python code also. Okay, the next one, that's all about classification. So in the classification, what are the hyperparameters? Any idea? So in KNN classification, the hyperparameters are k values, right? And the distance matrix, you are using the equal distance values, right? And the okay, so these are all coming under the KNN classification, right? And the next one is clustering. Okay, next one, clustering. So what is clustering? So clustering is an unsupervised machine learning technique. Unsupervised means what? Inputs known, outputs are unknown, right? Supervised learning, both input and output are known. We have the output column, right? But in the unsupervised learning, what happened? You know only inputs. We are unknown about the outputs. So how will cluster? So first we'll see, then we'll see the examples. So clustering is an unsupervised machine learning technique used to group similar data point together based on their characteristics. Means what? The data will be grouped based on the similarity. Okay, so the points in the same cluster means they are similar. The points in the different clusters they are dissimilar. Why clustering? The same case for classification. Why we need the clustering? For decision making, pattern prediction, and then what? Pattern prediction and pattern identification and the predictions also. So grouping customers by buying behavior, grouping news articles by topic, resonant anomalies, image segmentation, social network analysis. All these cases we are using clustering. The common clustering algorithms, K-means clustering, hierarchical clustering, and DBA scan clustering, and then Gaussian mixer models and all. So today we'll see about what is K-means clustering. Okay, so K-means clustering means it's unsupervised learning algorithm used to group the data into K distinct cluster based on similarity. So K represent what? Similarly for KNN. KNN classification, like what is K? K represent the number of neighbors you are going to consider for classification. Likewise, in K means clustering, K represent the number of clusters you are going to form. Okay, KNN, K represent the number of neighbors you are going to consider for classification. But in K means clustering, this K represent number of clusters you are going to form. Okay. So the steps in K means clustering. First thing is what? Choosing the number of clusters, K. So K set by the user. So it's coming under hyperparameter, right? The next one, initialize K centroid. So we are going to form K number of clusters. So for K number of clusters, we want to find the centroid. Based on the centroid only, you can group the data, right, into the cluster based on the distance value. So initialize k centroid. அப்படினா என்ன அர்த்தம்? Based on the k, if k equal to 3, we want to set 3 centroids. Okay. So for the clusters. So if this value also set by the user. So this is also coming under hyperparameter case. And the next one, assign each point to the nearest centroid. So based on the distance, equilibrium distance calculation, we will find overall nearest to the centroid, and the nearest points will be clustered with the centroid. Okay, coming under that cluster. And then recalculate the centroid for each cluster. So once all the points are centroid, the next time we want to again recalculate the centroid. I will tell you how to do, right? So again we want to recalculate the centroid because the first initial centroid set by the user only randomly, right? So the next time the machine, after some calculations, you want to calculate the centroid for the accuracy of the model, right? So we want to recalculate the centroid again. Okay, from the centroid again all the points you should be find the distance, and based on the distance value you can cluster it. So you want to repeat the step 4 and 5 again and again. You want to form the cluster and group the points and form the cluster. Okay, calculate the centroids, form, group the points. Okay, form the clusters. So these two steps will be repeated till there is no change in the previous iteration. So in the next time, if there is no change in the previous iteration, means we can stop with it. That is called convergence. So what is convergence? So convergence is nothing but getting the standard output. Okay, so continue updating centroid and assignment until the centroids no longer move or maximum iteration reached or clusters stabilize. Means there is no change in the current cluster iteration than the previous one also. Means you want to stop with it. Okay. So this is called convergence. So now we'll see. Then final outputs are what? K number of clusters, centroid positions, and labels. We can label the clusters also based on the features, right? So these three are the final outputs. So advantages of K means cluster. Simple and easy to understand, fast and easy, works well, and when clusters are well separated, scales to large data set, easy to implement, guarantees convergence. Okay. And drawbacks are specify K in advance. This is the major drawback, right? We want to say K value, number of cluster, how many cluster you want to form. So these disadvantage is overcome by some other hierarchical clustering and all. Anyway, K means we have one of the drawback here. We want to set the K value before training. Okay, so set by the user. And the next one, sensitive to outlier and noise, similar for KNN also. And works only with numeric data. Okay, and works best when clusters are round and equal sized. Non-linear means we have some problems. Means it will work, but the accuracy is more in this case. That's all. Sensitive to initial centroid position because the initial centroid are also set by the user. So the K value as well as this initial centroid sent by the user. So it's more sensitive to K as well as the centroid, initial centroid position, and no suitable for non-linear data sets. Okay. And this is the example now we'll see for K means we have 10 more minutes, right? Within that I want to finish. So this is the given data set. They have given, I told you already there is no output column because outputs are unknown. Only we know input for the unsupervised classification. So these are the inputs. We don't have the output. So how will predict the output? Based on the model implementation, right? So here our aim is what? We want to cluster the given data points based on their similarity, right? So the A value is 1 to 1410, D value is 10 to 10410. So initial value, we are starting now K means algorithm. So first value is what? Setting the K value. K equal to 2, we formed, right? And the next one, what? Centroid, initial centroid assignment. So from the given data set, I am initializing the centroids. So So I said what? How many clusters? K equal to 2. So I want to choose 2 centroids from the given data set. Okay, so randomly I have chosen A equal to 1, 2 for first centroid, and second centroid is D equal to 10, 2. So I have taken 2 centroids for 2 clusters formation, right? And the next one, now centroid is ready. We have the data set. The next one is what? Distance calculation, right? So from the data center, so means from the centroid, how much distance the points are occurred, right? We want to find. So for C1 as well as centroid C2. So the centroids are called as C1 and then C2 respectively. Okay. So I called centroid as C1 and C2. So we want to find the distance from this centroid to the data points. So 1, 2, I want to consider all 6 points, as well as from 10, 2, I want to apply all the points to find the distance calculation. So here used squared Euclidean distance means what? In Euclidean distance we have square root. If the Euclidean distance is squared, means what? The square root will be removed. So we just only see x2 minus x1 whole square plus y1 minus y2 whole square. Okay, so here we can take this as a x1 y1, this also x2 y2 also. So that's why y minus x minus x2, y1 minus y2, we get 0. Means what? The first, see here, for the second centroid, the distance value from the formula application, you will get 81. So which is nearest? So the point A is close to centroid C1 because the distance is 0. It's far away from C2 because the distance value is 81. So which is less? C1 is less. So the A point belongs C1 cluster, right? And the second, the distance is 4 for C1 and 85 for C2. Means what? The B depends C1 cluster. Likewise C cluster. The 4 and 85, which is small, 4. So C point depends C1 cluster. What about D? In D, centroid C1 has 81, but C2 has 0. Means the D depends C2 centroid. Means C2 cluster. Okay. At the E value, so C1 is 85, C2 is 4. Means what? The E depends C2 cluster. And F distance is 85 and 4. So 85, the 4 is very less. So F belongs C2. So now after this iteration, what happened? The cluster 1 has A, B, C points. Cluster 2 has D, E, F points. Right? So what is the algorithm for K-means clustering? After forming the cluster, again we want to recalculate the centroids. Right? How will recalculate the centroids? Take this 1 plus 3 points are assigned to C1, right? So 1 plus 1 plus 1 by 3, number of values, comma 2 plus 4 plus 0 by 3. See here, 1 plus 1 plus 1 by 3, comma 2, 4, 4 plus 0 by 3. So from this you will get the new centroid again for C2. So values are what? 10 plus 10 plus 10 by 3, 2 plus 4 plus 0 by 3. So 10 plus 10 plus 10 by 3, 2 plus 4 plus 0 by 3. So we have second centroid also. So now from this, again you want to calculate the distance from A, B, C, D and between A, right? So but look at here, the centroid is. What about the first iteration centroid? 1, 2, 10, 2. What about now the calculation centroid also? 1, 2, 10, 2. Same centroids, right? So no need to furtherly move because the same value only you will get. So there is no change in the centroid formation. So we can wind up to this, right? Then you finally say for the cluster C1, points are A, B, C. For cluster C2, the points are D, E, F are clustered. Okay, so this is for 2 clusters, right? The next example, so grouping students based on marks. So based on the marks, we want to group the students, right? So they have given max marks as well as the science mark. So totally 6 subjects are given, 6 rows are given, and the K values they said 2. Means what? Here there is no constraint for K odd value. In the KNN classification, what happened? We said K value as a mostly odd value because to avoid ambiguity. Because maximum voting will get the prediction. So, but here it's not mandatory, right? You can set K value as a odd number or even number because K represent what? Number of cluster you are going to form for the given data set. Okay, so K equal to 2 we set. Second step is what? We want to select the initial centroid, right? So initial centroid, the initial centroid we have taken from the given value. So 40, 45 is the first centroid. and then 85, 88, D value. So A and B are take it as centroids. So next value is what? After selecting K value and the centroid value, third one is distance calculation. So you want to calculate this, you take it as this value is x1 and this value is x2. And similarly for this value is x1 and this value is x2. So likewise, this is for y1, this value is y2, and this is for y1 and this value is for y2. So likewise, we can apply the equal distance. Here we use squared equal distance, so there is no square root. You can directly apply x1 minus x2 whole square plus y2 minus y1 whole square. Okay, so here for C1 the value is 0, C2 value is 3874. So this value is less. So this given A point belongs to C1 cluster. Likewise, the B belongs to C1 cluster and C belongs to C1 cluster. And D belongs to, this value is 0, right, than this minimum. So belongs to C2 cluster. E belongs to C2 cluster and F belongs to C2 cluster. So we formed A, B, C and D, E, F. Again, the next case is what? We want to form the new centroid. How will we form the new centroid? From this. So see here, the values are C1 belongs A, B, C, right? So how will we calculate for A, B, C? So the A value is 40 plus 42 plus 39 by 3. And then 45 plus 43 by 40 plus 44 by 3. So this happened here. Look at here. So 40, 42, 39 by 3, 45 plus 43 plus 44 by 3. So we will get the new centroid. Likewise for C2 belongs D, E, F. So D, E, F values are what? 85 plus 87 plus 84 by 3, 88 plus 90 plus 86 by 3. So the new centroid calculated here. Okay. Again, we want to consider all those things. Again, we want to calculate till there is no change in the previous step. If it is no change, we can stop went with that and we can declare the cluster 1 points and the cluster 2 points. Like, so here we have one more concept called sum of squared errors. So before enter into this, in KNN classification, we have the hyperparameters K values. And what about K means classification? The hyperparameters are K values, distance matrix, initial centroid values. Right? We set, right? And the non-hyperparameters are what? After initial centroid calculation, right? The machine will calculate the new centroid. So these are coming under non-hyperparameters. So after initial calculation, initial centroid, we have further centroid calculation set by machine. So it's coming under non-hyperparameters case, right? And then here one more point we have. This is called the sum of squared error. Sum of squared error means what? From the centroid, say for example in this example, cluster C1 has A, B, C points, right? So that A, B, C points, the centroid is what? 40 and the centroid values are 40.3. This is calculated by the machine, right? 40.33, 44. Okay, so this is the new centroid. So from this, we want to calculate the distance from A, B, C. So for A, the new centroid is 40.33 and 44, right? This value, 40.33 and 44. So the distance for A, B, C already classified to C1. The distance are calculated and we have to take the average. So the average value is 6.66. So in this case, we are setting some threshold. If the SSE value is less than the threshold, means the accuracy of the system is high. So if the threshold, if the value is SSE, sum of squared errors is higher, the threshold means the accuracy is very low now. Okay, so similarly for cluster 2 also. So the cluster 2 new calculator centroid is 85.33 and 88. And we already set D, E, F points into it. So we are calculating the distance and taking the average value is 12.66. Means what? The accuracy is low here, right? So if you set the threshold is 10. So the first cluster is clustered correctly. A, B, C or D depends only C1. But in the C2, it's beyond threshold 10. It's 12. Means what? We want to form one more cluster because D, E, F, some points may belong to C3 cluster also. So after this SSE, you can change the K value and you can recalculate for clustering also again because the K value is set by the user. It only approximated value. So based on the error factor, you can increase the K value to get high accuracy. Okay, so this is the K means clustering. That's why they found it here. And this is the Python code for KNN. So they introduced one more concept called K mean plus plus. What is it? In K means clustering, the initial centroid set by the user, right? So say for example, if the user, this is the very small, so you can directly take A and D. If it is the rows or lakhs and crores, so how will you take the initial centroid from it? It's very difficult, right? So there may be a chance for taking 1 comma 2 and 1 comma 4. If you take two centroids are nearest, so the accuracy will go down, right? In model. So in K means plus plus, what happened? The first in initial centroid setting, no, the first centroid set by the user, the remaining centroids will be set by the distance calculations. Okay, so remaining centroids will be calculated by distance calculation. That's why K means. So to overcome the drawbacks in K means, the K means plus plus will they introduced, right? Here what happened? The centroid initial randomly we have chosen, but here what happened? From the remaining, the pick the first centroid randomly set by the user. The remaining will set from the distance. So here also they use equidistant distance. So if the initial centroid is this one, from the distance only they can set the new centroids. So these are the features the drawbacks of K-means are overcome by K-means. Okay. So that's why the convergence speed is medium and fast, stability low and high. The complexity is low, likely, but it's somewhat higher, but worth it because the centroids are safe. So centroids are safe means the model accuracy will also good. So these two are the difference between classification and clustering. So classification we have discussed already, supervised and unsupervised. It requires labeled data, does not require labeled data. We are going to form this. You have the predefined class in classification. This is no predefined class. Okay, class labels are there. Here you are clustering based on the pattern matching. Here model is trained using input output pairs. Here model is trained only based on the patterns, inputs only, right? So classes are defined in advance, no predefined classes. Can measures accuracy precisions or that, but here there is no accuracy precision. That's why we are using sum of square errors, right? We have seen no that based on that we can find the prediction of the model. Okay, and then here the examples are SVM, KNN, Navy base and all. Here example K means hierarchical clustering and all. This is applications are spam detection. This is diagnosis. This is the applications are custom segmentation, image segmentation, and market analysis. So thank you all. So that's all about today's session about classification and clustering. So any doubts you can ask now. You may ask in chatbot also. Any doubts you have, you may ask. Harshini? Yeah, yeah. Am I audible? No. Yeah, yeah. Thank you. Any other? No doubts in classification and clustering or lazy learning. Lazy learning is also called instance-based learning. So instance-based learning means what? So the model will not be generated during training phase. It will be generated in test phase when the new instance is coming. Okay. So lazy learning. So KNN classification is coming under lazy learning. Okay, ma. And K means is not lazy learning. Okay. If no doubts, I can leave. Harshini, you can proceed here.
Yes, ma'am. On behalf of the Department of Computer Science and Engineering, Sri Venkateswara College of Engineering, I sincerely thank our esteemed speaker, Dr. Vinodya Lakshmi ma'am, Professor, Department of Computer Science and Engineering, for her insightful and well-organized session. Your clear explanation of classification and clustering concepts helped us understand the core ideas of machine learning in a simple and effective manner. I also extend my heartfelt thank you to all the participants for joining today's session and contributing to its smooth conduct. The feedback form for today's session will be shared in the chat. and we kindly request all the participants to take a moment to fill it. Thank you all.
Participants, you can fill the feedback form and you can leave. Thank you all. Kindly join sharply at 7 o'clock of today's session. Thank you. Harshini, I will read here. Harshini? Okay.